Hello everyone. So today I'm very honored to give a presentation about to introduce our work, SmartBrush Text and Shape Guided Object Inpainting with Diffusion Model. So I'm Sean, and this is a work with Zhifei, Zhe, Tobias, and Kun. So this is a work during my internship at Adobe. So as we know that the text-to-image diffusion models have been achieving very big success. So they can generate very high quality images according to the input text prompts. So therefore it inspires the text-guided inpainting with diffusion models. However, existing inpainting models just use the pre-trained text-image diffusion model, and then they random erase part of the image and train the diffusion model to recover it. For example, DALL-E 2 and Stable Inpainting. They just random erases the part of the images, the training images, and then train the diffusion model to recover it with the whole global image caption. However, as we can see here, there can be many failures. So the first challenge is that they're unable to follow the given accurate object mask. For example, here we have a input and mask, and we have a flamingo mask, and we have the text prompt as flamingo. However, the stable diffusion and the glide cannot fail to follow the accurate mask. And also, some methods, since they random erase part of the objects in the training images, so they are unable to follow the given text prompt. For example, glide and stable inpainting just recovers the mask area as background images, as we can notice here. So it's quite challenging to hear. So another challenge of object inpainting is the background preservation in coerced mask, because in many cases users only just input a coerced mask. So for example, like a bounding box and very wide region. However, if the user may just want to generate an object inside this mask region, however, it may fail to preserve the background in a coerced mask, as shown in the left figure. The input image about the door, we can see the mask. And then we can see that DALL-E 2 generates quite high quality car here inside the mask. However, we can notice that there are many unnecessary changes. For example, the doorbell has been extended, and which is unwanted, because users just want to generate car instead of changing the background. The main problem is that our input is a coerced mask, and so how can we preserve such background information inside this mask? So in this paper, we propose a text and shape guided object inpainting model. So we propose a new training diagram for diffusion-based object inpainting. Specifically, we utilize the text and shape information from existing instance segmentation datasets. So a very simple way would be we use the instance segmentation dataset like Coco and Open Images. So we just during training we just mask the images, we mask the objects, and add noises on the objects, and then we just input our mask and its corresponding object label. For example, like here we have a dog as the category label, so we input this text prompt into a diffusion model and train the model to denoise it. So therefore, now we are sure that the generated object during inference time will align with the text prompt, and also will follow the shape of the text of the input mask. However, it's also problem is that we would like to have users with shape precision control, because user providing mask can vary from accurate to coerced. Some professional users may draw a very accurate mask, and they want to generate something that exactly align with their input mask. However, some users are non-professional. They just draw a bounding box thing, and then they wish to generate something inside this bounding box, and they do not care whether the object should align with this input mask. So to address this challenging issue, in the training we generate masks with different precision, and we input a mask indicator to a diffusion model. For example, on the leftmost, we have an accurate astronaut mask, and then we just apply Gaussian blur iteratively, and in the final mask type, it will be a bounding box. Then we can input in the diffusion part. Then in the training, we can just input the model. We can input the model into this. We can input the model, input the mask type, and also its corresponding coerced mask into the model to let it know which mask it is input. And so then in the inference time, we can just input a mask type to let users decide whether the generated object should follow with the mask or not. For example, here is an example. In the input mask, we can let user decide the mask type, and then we will generate different masks. And then as the mask grows, as the mask type becomes larger from 0 to 4, the generated astronaut can gradually changes on a line with the given mask. And another challenge is about the background preservation. When we feed a coerced mask, it generates objects inside the mask, but other pixels are changed unnecessary. As we have said before, for example, the doorbell has been extended, and the flowers have been changed, and the islands have also been changed here. So to adjust this one, we additionally train a neural network to predict accurate mask from coerced mask. For example, on the right, in the training time, we input a coerced mask. So this is a type 4 mask. Then we just add a branch. Exactly specific, we just add a one output channel in the convolutional layer. So then this channel will be trained to predict the accurate object mask from the input coerced mask. And so we use the classical dice loss to train it. So then in the inference time, so we can generate object using the predict object mask. For example, suppose we can see that we have different bounding box input as coerced mask, and then our model, our prediction branch will learn to predict where the object will be generated and how the shape is. Then we can utilize this object shape prediction to further preserve background information inside this bounding box mask. So for example, here without this background preservation, the doorbell has been extended, and if we use this, we use our mask prediction, and then we can preserve more pixels inside this coerced mask. So here are some quantitative results. We achieve best results compared to this existing SOTA method, and we also have some visualized results. Here is a demo, and we build. So basically, we allow, given a mask, given a picture, so we allow user to draw some brushes, a mask, and then we can input a text prompt, Persian, for example, like here, Persian cat. So we will generate some Persian cat. Then we can gradually allow user to change the images, to edit images step by step. And finally, we can have something fantastic. And also here is an example of a man. So we can input gradually add a hat, cowboy hat, and with sunglasses, and then we have a blue shirt, and finally, so we have this result. So our method allows Inpainting and with high quality and efficiently, and that's it.